Welcome back. And we are going to be looking today at our lesson for when we are looking for either angles or arcs when the vertex of the angle is outside the circle. So this can be caused by a few reasons. A few different ways to make it so that our vertex is outside the circle. In this first example, we have a secant intersects the circle twice, and a secant. You do need to know your vocabulary, folks. In the second example, we have a tangent and a tangent. And in the third one, we've got a secant and a tangent. So if we have secant, secant, tangent, tangent, or tangent, secant, we end up with our vertex of our angle on the outside of the circle. It doesn't like for me to draw circles or points. Okay. So now we've got a formula to deal with this situation. In our other lesson, when the vertice for the angle was inside the circle, but not the center of the circle, just kind of floating somewhere inside the circle, we would add the arcs together and then we would divide by 2. Now that we have pulled the angle outside, it's going to make the angle smaller. So we are now going to take our large arc, like this would be the large, and this would be the small. We're going to subtract them and divide by 2. Our smaller arc is closest to our angle. Just take a look at that. Okay, speaking of which, just think about what happens to the measure of an angle when you move the vertex from the center to the outside. So here it is. Think about how big this angle is. And now I've moved it from here to here, and the measure of the angle has gotten smaller. So here it equaled the arc. We pull it back. Now it's going to be half the arc. And then when we pull it further back even, we get an even smaller angle. We are still intercepting the same arc. The size of AB hasn't changed, the arc AB. But now we're going to take this large arc, or I call it the far arc, minus the near arc, which is the small arc, and we're going to divide it by 2. So the way I like to work my formula is the measure of the angle equals my far arc, or I call farc, minus my near arc, which is my narc, divided by 2. Okay, and these were the things we just went over as far as the different ways you can make angles with their vertex outside the circle. 2 tangents, meaning they intersect the circle at 1 point. 2 secants, where they hit the circle at 2 points. And a secant and a tangent. So let's work some example problems together. Sometimes you have to find an angle. So now I'm looking for this angle X. Okay, and I'm thinking, okay, here's this all the way here. This is my 157 degrees. But this is my near arc right here, and I don't have the angle measure for it. But remember, there's 360 degrees in every circle. So all I have to do is take 360 degrees, and I subtract the 157 and the 93, and I think I get 110 degrees. That's my 360 minus my 157 plus 93. Now I'm just able to use my formula. My far arc minus my near arc divided by 2 equals my angle measure. And I can just, either put that in the calculator or, just figure it mentally. But it's going to be 47 divided by 2, so I'm going to get a little decimal. That's my angle measure. There we go. This one's already set up for me. Here's my vertex outside the circle. It's outside the circle. So I'm going to do my far arc minus my near arc divided by 2, and that equals my angle measure. So I'm going to take my 102 minus 38 and 64 divided by 2. I end up with 32 degrees equals x. Okay, this one will take us through it on the PowerPoint. I've got my far arc minus my near arc divided by 2 equals my angle. Here's another one. This time I don't know my near arc. I'm still going to plug it into the formula. My far arc minus my near arc divided by 2 equals my angle. Multiply by 2 on both sides to clear my fraction. I would subtract 70 and it would be a negative 16 equals a negative x. So positive 16 equals positive x. Okay, let's take a look at this one. Again, we have got the far arc listed for us. But we got to think about, what is this near arc? Remember, it's 360 all the way around. So 360 minus 260 is giving me that 100 degrees right there for the near arc. So then I just set it up. Far arc minus near arc divided by 2 equals my angle. X is 80 degrees. Now you can sing. I am not going to sing this for you on video. There's no way I am putting my voice trying to sing any sort of song on video for you. Let's move on to some more examples. You can pause the video here and you can sing it if you like. Here we go. All right, now sometimes we have to find the arc. We're still going to use the same formula. Here I'm looking for my far arc. So I'm going to have my far arc minus my near arc divided by 2 equals 40. First thing I'm going to do is multiply both sides by 2. 2 times 40 is 80. I'm going to add 67 to both sides, and I end up with my far arc x equals 147 degrees. This time I'm looking for the near arc. So 88 is my far arc minus my near arc divided by 2. It's 32. Multiply both sides by 2 to clear my fraction. It's 64. Now I'm going to subtract 88 from both sides. That's going to give me a negative value. So I have a negative x equals a negative 24. I could multiply by negative 1. I could divide by negative 1. I can think the opposite of x is the opposite of negative 24. Any way you want to think about it, you get x equals 24 degrees for that near arc. Okay. So now we're looking at a few extra problems. Find the measure of the angle or arc indicated. Assume that lines which appear tangent are indeed tangent. Okay. So here, we're going to set up our formula. Far arc minus near arc divided by 2 equals our angle measure. That's what we're looking for. So 209 minus 99 divided by 2. I'm going to label that as x. So when you solve, you get 55 degrees equals x. Looking for the angle measure. Remember, this is an entire circle, so this is going to be 100 on your near arc. So 260 minus 100 divided by 2 equals your x. 80 equals x. Okay, well, let's think about this one. Now we've got this arc, and we got to think, how are we going to solve this one? Well, if I label this x, this is what I'm looking for. This out here is equal to 360 minus x. So if I set it up, 360 is my far arc, 360 minus x is my far arc, minus my near arc, divided by 2 equals 65. Multiply both sides by 2, and I'm going to drop my parentheses. 360 minus x equals 130. 360 minus 2x It's 130. Okay, so then I'm going to subtract 360 from both sides to get a negative 230. Divide by negative 2, and x equals a positive 115 degrees. So let's think about it along those same lines for this one. Okay, I'm looking for this angle. This is 60 degrees, and it's a tangent. So what we can say with the vertice here, not vertice, the edges here, when we have two tangents and this angle right here, the arc caught between them is going to be double that amount. So that's 120 degrees, okay? So now I know that this is going to be 360 minus 140, which is 240. Okay, I want us to think about this one. Well, let me reapproach this one. We'll do it in the same vein as the other. You'll see this one. If I label this one as x, and this is 360 minus x. We'll look at it the same way. My 360 minus x divided by 2 equals 60. I end up with 360 minus 2x equals 120. A negative 2x equals a negative 240. And then x equals a positive 120. So that's going to give me my 120 here as well. And then 360 minus 120 will equal my 240. Okay, got a couple more examples we can work together. Probably will not get them all in on this video, so I'll make another video so that we don't have to rush through them. Okay, we're going to solve for x, assume the lines that appear tangent are tangent. We'll try to finish number 5 here. So I've got my far arc minus my near arc divided by 2 will equal this angle measure. So 136 minus 66 divided by 2 equals 8x minus 5. Well, I have no variables on this side, so I can just go ahead and solve that 136 minus 66 and divide it by 2, and I end up with 35. So 35 equals 8x minus 5. Add 5 to both sides. Divide by 8. X equals 5. Okay, I think we might have time for one more. 189 minus 103 divided by 2 equals 43x. Again, there are no variables on the left-hand side, so I can just do the math, and I end up with 43 equals 43x, divide by 43, and 1 equals x. All right, kids, I'm going to stop here, and we'll pick up with the rest of our examples on our next video.